All right, so in this video, we will cover truth tables. So let's talk about some new symbols that we will use for truth tables. So we talked about and, or, and not in prior videos. In this video, we're going to use some symbols. This little upside down V, it's called a wedge. We'll use it to symbolize and. The V, we'll call it V, is symbolizing or, and this squiggly is what we're going to use for not. So we're firstly going to translate these statements into symbolic notation. So if I say something like P is I like Pepsi, C is I like Coke, how would I translate I like Pepsi or I like Coke? I could translate this into the statement P, and I would use the V for or, and then C for Coke. So this is a symbolic expression of I like Pepsi or I like Coke. If I say I like Pepsi and I like Coke, I would say P and C. So that wedge, we're going to use that for C. And then for I do not like Pepsi, I would say squiggly P for not Pepsi. Or what about this? It is not the case that I like Pepsi or Coke. So I would say squiggly Pepsi or Coke. We'll find out later this is equivalent to saying I don't like either. I don't like Pepsi and I don't like Coke. Okay. Lastly, I like Pepsi and I do not like Coke. I could say it this way: Pepsi and I would say squiggly C, I don't like Coke. Okay, so you'll have some practice. That's our first skill for this section, to practice translating statements into logic. And what's next is we're going to break down, when we have a logical statement, what all the possible outcomes could be and which of them satisfy our logical expression. So let's get into it. So here's what we call a truth table. If A and B are two events, A would be the first event, B is the second event. What I'm going to do in this first part of my truth table is that I'm going to enumerate, that means list, all the possible outcomes. Either A is true and B is true, or A is true and B is false, or A is false, B is true, A is false, and B is false. You can think about this as considering all outcomes. In fact, you should check this with your understanding. Are there any more outcomes that we could have for two events that are true and false events? So since we've listed them all, the next thing we can do is start making compound statements. For example, A and B, the conjunction. Oh man, just move documents. The conjunction would be true when both A and B are true. A and B means they both have to be true. So that's when it is true. But everything else here is false. If one of them is false, the whole statement is false. So that's how the conjunction statement works. Remember, that's and. Oh man, what just happened? Okay. So conjunction is and. Disjunction is or. Again, if we list all possible ways we could have A and B occur, we're going to look at the outcomes of our combined statement, A or B. So A or B is true when any one of them is true. So if A or B is true, it's true. And this is inclusive or. If both are true, that means yes, one of them is true. That's what we're talking about with the disjunction. If even just A is true but B is false, it's still true because one of them is true. B is true but A is false, it's still true. And it's only false when both are false. So that's the conjunction. These are kind of standard patterns of logic that we'll see. The last one is the negation. Negation just takes the opposite. So if A is true, not A is false. A is false, not A is true. So we're going to practice making a truth table for A or not B. So how am I going to set this up? It's always going to include A and B as my first two, where I just list all the possible outcomes. And I like to be consistent. I hope you do too. If we list them like this, true, true, false, false, true, false, true, false, we'll get all the outcomes. Now what I really need is this not B here. That's confusing. So I'm going to first find not B before I find my combined statement A or not B. It makes it easier for me to evaluate if I break it up like that, because this is easy. True becomes false, false becomes true, True becomes false, false becomes true. That's what the not says. I negate that statement. So in the case that A and B are true, that means not B would also be false, right? And so it's a systematic way to arrange it. Okay. Next, I want to find A or not B. So that means either A has to be true or not B has to be true. As long as one of them is true, according to this table here, we're going to say true. Now, if both of these are false, then the outcome will be false. So let's look at it one by one. And I'm going to use a different color here just to highlight what I'm looking at. I'm looking at this column for A and this column for not B. And all I care is that either one of them is true. So is either one true? Yep, we got one true. Is either one true? Yep, at least one is true. Now here, is either one true? No, both are false, and that's the case, so we have to say false on my table. And is either one true here? Yes, not B is true. So the evaluation of the statement, A or not B, would be true in these outcomes and these outcomes, but in one case, it's going to be false. When A is false and B is true, that's the time when A and not B is false. So I believe that'll be your quiz question, and we'll see you in class for more practice. All right, thanks for watching. How do I? Oh yeah, Control-Alt-H.